Welcome back. In this video, we're going to go over section 4.4, which is about the slope of a line. So we've seen how to graph lines given 2 points. Basically, you draw the 2 dots and then connect the dots. In this section, we look at slope, which is a measure of how steep a line is. And fortunately, it's mostly pretty intuitive. So taking a look at the pictures below, assuming you read left to right. As we look left to right, which one increases more rapidly or is more steep. So taking a look at the leftmost picture, it should look like line A is steeper than line B. And that's true. In the middle picture, we have a line A and a line B again. This time A goes down as you look left to right, and B goes up as you look left to right. So out of the two, which one would you guess would have a negative slope? If you guessed A, then you guessed correctly. A would be negatively sloped, whereas B is positively sloped. And then in our last picture, we have a line A, which is negatively sloped, and then a line B, which looks like it is horizontal. If you had to guess whether one of these had a 0 slope, you'd probably guess B, and you would be correct. So as you look left to right, the steeper the line is, the bigger the numerical slope will be. And if the line goes down as you look left to right, you'll get a negative slope. And if you have a line that is horizontal, it's going to have a 0 slope. Okay, so the way that slope can be calculated is in terms of, some people say, rise over run, which is a vertical change divided by a horizontal change. So we could think of it as a change in the y-axis direction divided by the change in the x-axis direction. So let's try it on the line pictured here. So what I would do is try to find two points that are exactly on the intersection of two lines. So here, that point where it crosses the x-axis, it's between 3 and 4, but I can't tell exactly where. I'd be better off trying to pick one where it's really obvious that it's on a corner. Like maybe this point, it looks like 2, -2, and then maybe 0, -5. Okay, so then if we wanted to calculate the slope, we'd have to think about if you're going to go from one point to the next, how much vertical change it would take. From -5 to -2 would be a vertical change of 3. I'm going to put +3 on there for emphasis. And then we'd have to make a horizontal change of 2. So the slope is 3/2 or 1.5 if you like. It's important to note that on a straight line, slope is constant, so it doesn't matter which 2 points you choose. If we used the point 4,1 instead, and let's say along with, let's use 2, -2 still. Let's calculate the slope using those 2 points. Well, here it would take a vertical change of 1, 2, 3, followed by a horizontal change of 2. That's still a slope of 3/2. Also, if instead of going from the lower left to the upper right, if you went from the upper right down to the lower left, you would also have the same result. Okay, let's try this line. This line, based on our intuition, looks like it should have a negative slope. So let's figure out 2 points. This one over here was the first one I saw. It looks like -4,5. And then we also have the point 2, 2. Okay, so then in order to go from one point to the next, it looks like I have to go down by 3 and then increase by 1, 2, 3, 4, 5, 6. So the x increases by 6 when the y decreases by 3. So you could say rise over run is -3/6. I don't actually especially like this terminology, rise over run, because as in this example, it's not exactly rising, right? It's going down, not rising especially, but there you have it. So -3/6 simplifies to -1/2. And that makes sense too. If we were to think from this point 2, 2, could we go down 2 and right 4? 1, 2, 3, 4. That would be a decrease of 2 and an increase of 4. Negative 2/4 is the same as negative 1. Notice this line has a negative slope, and that's consistent with our expectations, given that it goes down as you look left to right. Okay, next, we want to look at some horizontal and vertical lines. A horizontal line has slope 0. A vertical line has undefined slope. So to see that, let's make a quick sketch of each line. If you have the line y equals 10, it might have the point 1, 10, and 8, 10 on it. In this case, the rise or vertical change is going to be 0 when the horizontal change is 7. And 0 divided by 7 is 0. That's a horizontal line and has a slope of 0. For x equal 3, a line that is vertical with equation x equal 3, that might have the points, say 3, 2, and 3, negative 5 on it, let's just say. So then the rise from negative 5 to 2 would be 7. And then the horizontal change is 3 minus 3, or 0. It doesn't change at all horizontally. 7 divided by 0 is undefined. Vertical lines have undefined slope. Horizontal lines have 0 slope. Okay, next up, we're going to take a look at a formula for slope. We want to be able to calculate slopes of lines without having to make the graph. So how can you do that? So we can use a slope formula to help us get this done. So we have 2 points on the graph, x1, y1, and x2, y2. Before we continue, I want to take a minute to talk about the variables having subscripts. The numbers after the x and y, here x2 and y2, those don't mean that we're multiplying by 2. Similarly, x1 and y1 don't mean that we're multiplying by 1 either. They are just indicating that we have more than one x and more than one y, and so we can refer to them without getting confused as easy. Here, x1, y1, x2, y2. The vertical change is then the difference in the x's, y2 minus y1, y2 minus y1. And then in the bottom, the horizontal change, x2 minus x1. Again, with the subscripted variables, if I had just used different letters for this, maybe A and B and C and D, then the formula for slope would look like the change in y, which is D minus B over C minus A, the horizontal change. Having it that way, you have to remember how the picture is labeled in order to remember which one's which, right? It's easier just to think like, okay, the difference of the two y coordinates divided by the difference of the two x coordinates. That's easier than if we'd labeled it with all different letters. That's why we use x1 and x2 and y1 and y2 to make it easier to remember. Okay, let's try to use the formula to calculate the slope of the line between the points 1, 2, and 5, 3. So let's do that. Tradition, by the way, has the letter M used for slope. So that'll be the change in y divided by the change in x. Okay, so you may ask yourself, okay, well, which point is which? Which one is the x1, y1? It turns out that it doesn't matter as long as you're consistent. I'm going to, for this first one, take the 1, 2 as point number 1 and 5, 3 as point number 2. So then y2 will be 3, y1 is 2, and then for the x's down below, we'll have 5 minus 1. 3 minus 2 is 1 up top, and 5 minus 1 is 4 down below. So our slope is 1/4. If we had made the decision the other way around and made it so that 1, 2 was point number 2 and 5, 3 was point number 1, then the calculation would look like this. We'd have 2 minus 3 in the top, and then 1 minus 5 in the bottom. This would give us negative 1 divided by -4, which is still 1/4. So it doesn't make a difference which point you take to be the first point as long as you're consistent about it. It would be wrong for us to switch halfway through to make 3 minus 2 divided by 1 minus 5. Okay, here I subtracted from right to left for the top, 3 minus 2, but then in the bottom I subtracted from left to right, 1 minus 5. So that's wrong. That's probably the number 2 mistake people make with this. The number 1 mistake is putting the x change on top. Okay, so remember also that it's the change in the y's on the top, the change in x on the bottom. So also wrong would be to have 5 minus 1 over 3 minus 2, or 4 for the slope. Remember that it's the y change on top, not the x change. Okay, so now let's try this again. We want to find the slope of the line that passes between 4, 0 and -2, 1. All right, so let's make the calculation. So again here, I'm going to rewrite the formula once more. M for slope is y2 minus y1 divided by x2 minus x1. Rewriting the formula every time you use it helps remember the formula, and it also helps us put the right things in the right places. So I'm going to subtract right to left. So up top we'll have 1 minus 0. Down below, -2 minus 4. Okay, so up top 1 minus 0 is 1, and -2 minus 4 is -6. So we'll have -1/6 for our slope. Okay, let me show how the work looks if you made the other choice. So this would have been 0 minus 1. If you went left to right, up top you'd have 0 minus 1, and then 4 minus -2. You got to watch out for those double negatives, but you would still have ended up with -1/6. Okay, so that's calculating the slope of a line. Okay, the next thing we want to look at is how you graph a line if you're given a point and slope. We've seen how to graph a line using 2 points, such as a slope, a y-intercept and another y-intercept, or just any 2 points. You draw the 2 dots and connect the dots. How do you do it if you have the slope and a point? So let's see how this goes. So we want to graph the line that passes through the point 1, -2 and has slope 3/4. So let me go to 1, -2 and draw a dot. Okay, the slope is going to give us a recipe for how to get to elsewhere on the line. So remember that the 3/4 is the rise over the run. And so from the 1 point I have, we will go up 1, 2, 3 units, and then we'll go to the right by 4 units. Okay. Let me draw that in. So that's a vertical change of 3, and then a horizontal change of 4. Draw that. Okay, and that gives us a second point on the graph. Note that we could have gone elsewhere, although this was easiest. There are a lot of fractions equivalent to 3/4. If our grid had permitted, we could have gone up 6 and right 8, because 6/8 is the same as 3/4. If you had so chosen, you could have gone down 3 and left 4, because -3/4 is the same as -3 divided by -4 is the same as 3/4. Okay, so let's try that again. So now we're going to graph a line that passes through -1, 3, and we're going to do 2 of these. We're going to have one that has a 0 slope and one that has an undefined slope. So -1, 3, -1, 3 is this point. If we wanted to have 0 slope, that means it's going to be horizontal, right? So a line with 0 slope is horizontal. That'll be A, and this is our line y equals 3. Okay, if we wanted to have an undefined slope, that will mean that it's vertical. And that'll be the line x equals -1. Notice on that, there wasn't really any calculation to do. Okay, a couple more graphs to do. So maybe pause the video and see how you've done, graph it, and then restart the video and see how you've done. All right, so for this one, we're going to graph the line that has a y-intercept at 0, 1, and then a slope of 1/2. Okay, so the slope is 1/2, so we could go up 1 and right 2. That will do it. So I had the point 0, 1 and the point 2, 2 on the graph. Okay. Again, that wasn't the only choice we could have made. Since the slope was 1/2, we could have gone up 2 and right 4, could have gone down 1 and left 2, and that would still have taken us to other points on the line. Okay, so let's try another one of those. We want to graph the line that has a slope of -2/3, but passes through the point 2, 1. So there's our point 2, 1. The slope is -2/3. Remember, with a negative fraction, there are a couple of places that you could put the minus sign. You could put it out in front of the entire fraction, or in this context, it's nice to put it in front of either the numerator or denominator. Most of the time, people put it in front of the numerator, but you don't have to. -2 divided by 3, the same as 2 divided by -3. So if we look at it the first way, -2/3, this means that to get another point on the line, we will go down 2 and right 3. Okay, so let me go down 2 and right 1, 2, 3. Okay, or instead, we could go up 2 and left 3. So from our first point, which was 2, 1, we will instead go up 2 and left 3. Okay, so our original point was 2, 1. We went down to 5, -1 by going down 2 and right 3. Or we could have gone up by 2 and left 3. Those takes us to two different points on the line, but either way is okay. Okay, let's try one more. We're going to graph the line that has a slope of -1/4 and an x-intercept of 5, 0. Okay, so there's the point 5, 0 right at the edge of my grid. Our slope is -1/4, so I could go down 1 and right 4. But taking a look at my picture, that would take me off my grid. And so while there's nothing wrong with the math, is in a practical sense, it'll be easier if I go up and left. So we'll look at this as up 1 and then left 4. Okay, so let me go up 1 and left 4. That will take us to the point 1, 1. Okay, that takes us to the end of this section. We took a look at a kind of intuitive way of looking at slope. As you look left to right, does the graph go up or down? And from there, we developed a formula for the slope, the change in y divided by the change in x. And we used it to calculate slope for a few different pairs of points. And then we looked at how to graph a line using a point and the slope. So that takes us to the end of this section. Let me know if you have any questions and have a great day.